Hello, and welcome to our roundtable discussion on best practice, part of the series on AI on real world data science. Over the course of this series, we've had articles laying out the nitty gritty of what AI is, how it works, or at least how to get an explanation for its output as well as burning issues around the data involved, evaluating these models, ethical considerations, and the impact on society, such as workforce and so on. With me today, I have a collection of data science experts well versed in how all these things play out in practice. And over the course of the next 45 minutes or so, we're going to toss around all these ideas to turn over some gems of advice for practically working with AI. I'm Anna Deming, freelance science journalist and guest editor for this real world data science series on AI. And with me for today's discussion are Janet Basterman, Napier Chief Data Scientist and Chair of the Royal Statistical Society Data Science and AI Section, Jonathan Guyard, Professor of Statistics and Data Science at Cardiff University and a member of the Real World Data Science Board, Ali Al-Shabazz, Academic Director in Digital Skills at the University of Cambridge in the UK, and Fatima Torabi, a Senior Research Officer and Data Scientist in Health Data Science at Swansea University, and also a member of the Real World Data Science Board. So thank you very much, all of you, for joining today for our roundtable discussion. To start off with, you've probably all heard the statistics. Almost everybody's now trying to leverage AI in their projects, and most of the projects are failing. So I thought it would be worth digging out some nuggets of wisdom that the panel might have for people who want to swell that minority that actually do succeed with their AI projects, and perhaps what you should do before you start doing anything. Does anybody want to start off this part of the discussion? Ali Al-Shabazz.
Thank you, Ella, for this opportunity. Yeah, it's not an easy to start, especially for people who are not aware about how the AI work, actually. But my advice is, first, they have to understand the basics of how AI, because the expectation could be over-promising from their side, and that is the danger. AI, it's just basically 25 years ago, master dissertation was about developing a simple, we call it simple now, but it was a master 25 years ago, a model with a neural network of combination of to classify data, whatever the data is. It could be drawing shapes, simple shapes, square, circle, triangle, and just classify them. That was worth of MSc. Now kids can do it. But understanding that it's a basic, the neural network or the AI, it's a simple of matrix with numbers, and actually the learning process, it's do multiple iteration to find the best combination of these product of sum of product of these numbers to classify, to do something. So actually the simple AI, it's a matrix of numbers, and to have these combination and train them for a certain situation, and that is a supervised learning. Now, when we move on over the last 25 years, especially in the last 10 years, because of the computational power is getting better, the AI now is working better. The other things they have to learn, it's the statistics as well. People, they would like to work in AI and data science, of course. They understand the data. And also, they should be expert in the data itself. So I can talk about cybersecurity. I can talk about networking and other things. But if it comes to something regarding the health data, yes, or financial services or stock market, I'm not an expert in the data. So I'm not going to be active working on and expecting me to work, even if I use the same AI tools. So this is in a nutshell how I thought about why people they fail sometimes using AI or they succeed using AI. So I don't know. That's my opinion. What other colleagues they feel, panelists.
So it sounds like it's important to value the expertise of data experts in those fields.
We should emphasize not only that, you should emphasize the human value. Even the AI is there. They will exist to help us to make better, accurate decision, but the human value is still there. And please, we have to insist on that.
Right. Thank you very much, Annie. Does anybody else have anything to add? Janet?
Thank you. I mean, I'd just like to build on all of that, the great stuff that Ali's just said. But when you look at basically the non-data scientist side of it, you often get businesses who think AI can solve this problem, and they might go out and hire a team, or whether that's sort of directly or indirectly, and get them to try and solve a problem that, as Ali just said, they may not have the domain expertise, that the business might not even have the right data. AI might not even be the right way of solving that problem. And I think that's one of the fundamental things to think about, is really understand what you're trying to solve and how you're going to solve it before you start throwing complex tools and potentially very expensive teams. And when you look at a lot of the failures, it's been because businesses have just gone, we can solve this problem. I'm just going to hire a team and let these intelligent people look at something, and then they're restricted on the data that they've got. It won't even answer the question. They're restricted on the resources they have, and even wider buy-in from the company. So really understanding, what is it that you want to solve? What are you trying to do? Is AI the right thing? And can you even do it with the resources you have available? And I think that's a fundamental starting point, because you can have wonderful experts, who have that domain knowledge, who understand the statistics, all that essential stuff that Ali just said. But then if from a business point of view, if you don't give them the right data to work on, or you don't let them do their job and tell you when they can't do their job, then again, you're going to be doomed to failure.
Thank you very much. It sounds like there's an awful lot of potential pitfalls, as well as not having the expertise specific to the task on hand. And Ali, you also touched on expectation management at the outset, but it sounds like there's also the underestimation of the resources that might be needed, and outsourcing too much of the expertise and not having a fit with the company. And so, does anybody else have anything they'd like to add? John?
Yeah, explainability is a big issue when it comes to AI models as well. They're at the moment very largely black box. Data goes in, then these models get trained on the data, and answers get popped out. And when it works well, it works fabulously well. We've seen lots of examples of that happening. But often for business, industry, or real life, we want to learn. We want to understand the laws of the universe. We want to understand the reasons why this answer came about. And I think as this explainability piece is missing, because everything is hidden away almost, I think that's a big issue in successful execution, and particularly when it comes to industries where there's a degree of regulation there as well. If you can't explain how a particular input arose to a particular output, then how can you justify to regulatory bodies that what you've got is satisfactory, ethical, and that you're learning and you're doing things in the right way?
Right, yes, explainability. So there have been efforts at trying to get explanations from these things. How close do you think we are to how do you think things are progressing there?
Yeah, that's a good question, Matt. I think where we are with explainability is in very simple scenarios, very simple models. And this is where traditional statistical models do very well. There's an explicit model which says if you put these things inside, then you'll get this output. So I think we're actually very far away from having that complete explainability picture, particularly as we fetishize more and more grand models. So the AI models are only getting more bigger, more complex, and that makes the explainability piece even more challenging. And that's why I think, as Ali says, at the moment, the human in the loop is absolutely crucial. And what AI does share with classical statistics or classical data science, if you want to call it that, is it still can only be as good as the data that's put into it. That's still a fundamental truth. I think a lot of the assumptions currently with AI models, and this is where there could be a few trip-ups, is that it can create something from nothing. It's artificial intelligence. Almost the wording suggests it's artificial. But fundamentally, we still need a robust and reliable, comprehensive source of data there in order to train these models in the first place.
And so coming back to Janet's point, something you touched on, Janet, in terms of having outsourced expertise for these projects, does that make it more problems if you're trying to understand what this AI has gone and done?
Oh, hugely. Let's say that domain expertise, and is something Ali touched on. You've got to understand your data, because even that fundamental initial preparation of data before you try and train anything is absolutely crucial. Sort of really looking at where are the gaps, where are the assumptions, how has this data even been collected, has it been manipulated before you got to it? And if you don't understand your industry well enough to know where those pitfalls might be, it's very easy, and a lot of teams do this. They just take the data and then they just put it in and they churn the handle and out comes something, and it looks like it's okay. But what they're really missing there, because they're not putting that effort in to really understand those inputs and what the models are doing, is they'll just keep churning the handle until they get something that feels about right. And then they'll go, okay, we'll just let a human do the other bits. What they miss out is where it goes wrong. And there are some industries where the false positives and false negatives from classification, or the bad predictions from things, really have a severe human impact. And if you don't understand what's going in and the potential impact of what comes out, then it's very, very easy to just, churn these things out and go, oh, it's 80% accurate, that's fine, without really understanding that human impact of the 20%. I mean, going back to what John said about that explainability, so crucial, because it is challenging and it is difficult. But going from these opaque systems to more transparent systems, we need that for trust. And as humans, we divulge sort of our trust very differently depending on the impact. So, I mean, one of the examples I use all the time is like, sort of weather prediction stuff. We don't really care too much because it's not got a huge impact. But when you look at sort of financials or medicals, we really, really want to know that output is good and how we got to that output. And, the Turing Institute's come out with some great research that says, as humans, if another human told us something and we want to understand why, we want the same thing from the models. And that can vary from person to person. So building that explainable level into everything we do has to be one of the things we think about up front. But yeah, you've got to really, truly, deeply understand that data. And it's not just a question of offloading a data set to sort of a generalist who can churn that handle. Otherwise, you will end up with huge, huge problems.
And talking of where there's a massive human impact, Fatima, working in health, I can imagine that was one of the examples Janet cited as having a huge impact, human impact. Do you have anything to add in terms of what you might want to do before you do anything?
Yes, sure. I think I very much agree with all the points that my colleagues raised, but I think it's very important that we know why we are doing this. Having those incremental stage in our planning for any project, and then having a vision of where we see AI can contribute into this process, can give us further efficiency, and how is very important, because if we don't have defined measures to see how this AI algorithm is contributing to this specific element of the project, we can really get lost into bringing these capabilities on board. And with a click, yes, it generates something, but how we are going to measure that something is very important. So I think as members of the scientific community, we all must view AI as a tool. It's a valuable tool. However, it has its own risks and benefits. So, for example, in healthcare, when we use AIs for risk predictions, it can really be a great tool to aid clinicians to save time. However, in each stage, we need to assess data quality, how these data being fed into algorithm, what procedures, what models, how we generate those models, and then which discriminative models do we use to balance the risk and then eventually predict the risk of outcomes in patients. So yeah, I very much agree with all the points that are raised, and I think it's very much of a balance between risks and benefits for usefulness of these tools in practice.
Right, so it sounds like start with why is also another good practice, and you have that in mind as you're taking apart your process and working out how best to go through it. Latmi, you also contributed, you were co-author on one of the articles on data, and I thought it might be helpful to move on next to, we have all these brilliant ideas of what best practice is, but in real terms, sometimes it's a little bit tricky to follow through. So I wondered if you could give us some thoughts on the sort of best practice with data that doesn't quite turn out to be quite so easy to follow in practice, and what you might do about it.
So I think the data is, we always call these AI algorithms data-hungry algorithms, because the models that we fit require to see patterns in the data that we feed into them so that the learning happens. And then the discriminative functions come in place to balance and kind of give a score to where the learning is happening and the evaluation of each step. However, the data that we put into these algorithms comes first, the quality of that data. And often in healthcare, the data is, because of its sensitivity, is held within a secure environment. So we cannot, at this point in time, expose an AI algorithm to a very diverse example, specifically for investigating rare disease or rare conditions. And above that, there's also complexities in the data itself. So we need to evaluate and clean the data before we feed it into these algorithms. And the diversity of the data itself, for example, the tabular data, the imaging data, the genomics data, each one requires its own specific or tailored approach in data cleaning stages. And we also have another level that is now being discovered in the health data science community, which is generation of synthetic data. So we can give access to AI models to the synthetic version of the data that we hold. However, that has also its own challenges, because reading the patterns from real data and then creating those synthetic version of data. For example, Dementia Platforms UK is one of the pioneers in developing this. And we hold a range of cohort data, patients data, genomics data, and imaging data. In each one of these, when we try to develop those processing algorithms, there are specific tailored approaches that we need to consider to ensure whether we are actually creating a low fidelity level of data that is holding some of the patterns in it for the AI algorithm to allow the learning to happen. However, it also is safe enough so that we can sign and ensure the data provided that these are secure data to be released for use in a lower governance level compared to the actual data. So there are quite a lot of challenges that comes, and we captured a lot of it in our article that you referred to. But yeah, I'm keen to also hear what is happening in the other disciplines, because it might be a lot of points that we can cross-learn in healthcare.
Yes, so on that note, does anybody else have any points they want to raise on maybe not just the data, but the evaluation or the dealing with the ethical considerations, where you know what the best practice is, but hit hurdles trying to put that into the real world? Ali, have you got something? Did you?
Yeah, I can talk about the cybersecurity and other the relevant data network security, and that's the amount of data we receive to analyze. It's really huge. When I say huge, when I say about 1 gigabyte probably in a couple of hours, or 1 terabyte in a week, that's a huge. And I always use the measurement of what does it mean by, say, 1 gigabyte. So 1 gigabyte of a text file, if I printed out this text file with A4, that leads me to a stack of A4 paper 3 times Eiffel Tower. So I always give this example for non-technical people to imagine the amount of data. So now, if I have a cyber traffic and try to detect any cyber attack, AI helps on that. However, if we train this model properly, and they have to detect that on real time. When I say real time, we're talking about microsecond or millisecond. And the decision has to be correct. So, and AI alone doesn't help. So humans should also intervene. So rather than having 100,000 record to check or a suspected breach, AI can reduce that to rather than have 100K, it could be 100. And the human can interact on that. And then in terms of the authentication or verification, yes, ongoing human and AI can learn whether this is a false positive, or this is a real attack, or just it was false negative. But this is a challenge in the cybersecurity area. I can talk about another area, but the issue is how can we have these kind of people to train? And then I can talk about the course which we developed and the challenges we faced how to teach them, what to teach the people to make them experts to deal with the data. So I will ask now just Janet to try to say something. Then I come back to talk about how we did it to develop this kind of courses. Thank you.
Thank you, Ali. Janet?
Yeah, so I just wanted to dive in sort of from the finance side. The data side is critical. We do have very large amounts of data, and I think we probably suffer from the same sort of problem that Ali does, in that, I'm trying to detect things, but there are people on the other side actively working against what I'm trying to detect, which I suppose is a problem that maybe Fatima doesn't have in healthcare. But when you're trying to build models to look for patterns, and those patterns are changing underneath you, it can be incredibly difficult, because I have an issue that all of my clients' data legally has to be kept separated. Some of it has to be kept in certain parts of the world, so we can't put that into one place. We can try and create synthetic data that has the same nuances of the snapshots that we can see at any one point in time, and try and put that together in one place. But what we can detect now will very quickly not be what we need to detect in a month's time, because as soon as transactions start getting stopped, as soon as suspicious activity reports are raised and banks are fined, everything switches, and how all of that financial crime occurs changes, and it's changing. It's like big scale worldwide, but also subtly, because you know, I know that there are a team of data scientists on the other side trying desperately to circumvent the models that me and my team are building. And it's absolutely crazy. So I would love to be able to pool all of the data that I have access to in one place and get that huge central visual view. But legally, I can't do that because of all the worldwide jurisdictional laws around sort of data and keeping that in certain places. And then we've also got the ethical side of it, which is something that Fatima touched on, in that, you know, if I get it wrong, that can have material impact on usually some of the most marginalized in society, because the profile of some of the transactions that that highly correlated with financial crime are also highly correlated with people sort of like borderline poverty, even in Western countries. So false positives in my world have a huge ethical impact. But at the same time, we're trying really hard to minimize those false negatives. So that balance is critical. And the data side of it's such a problem. You know, so Fatima mentioned sort of the synthetic side of it. That is something that there's a huge push, particularly in the UK, to get good synthetic data to really showcase some of these things that we're trying to detect. But by the time you get that pooling and the synthesizing of data that you can ethically use and you can sort of share around without fear of all the legal repercussions, what we're trying to detect has already moved on by that time. So we're constantly several steps behind. And I imagine Ali's got a similar problem sort of in the cybercrime space, is that as soon as things are detected, the ways in which they work move on. So there's an awful lot, I think, that as an industry, even in our different verticals, we can share best practices on.
Right, another really interesting point is how synthetic data can help with some of the issues you have around legal or ethical data details, but there's a need for speed. Ali, what was it? What was the other point? You were talking about how there seemed to be a demand for new types of expertise as well.
Well, there is a huge gap in the UK, at least worldwide, about finding people as a data scientist or working with the data. So we created a course in Cambridge we called it Data Science Career Accelerator. So for people who are working with the data, and they would like to move on and learn more. And what we actually did, we did a market research, and we interviewed around 50 between CEO and head of security and head of data science department in the industry to tell us what kind of skills you are after. What are the problems currently you have? And then we designed this course, and we found that there are, first of all, people, they don't know from where to start, what kind of data, what are the tools they have to learn. Even if they learn the tools, what kind of machine learning process, and then suddenly we have ChatGPT turns out, and the LLM development, and all of that in one course. It is a real challenge. But the course started now, this first cohort, and the good thing about it, or the big advice from the industry, and it's the students or the learners, they have to work during the course on a real world case studies or scenarios with the data nobody touched it before. It's not a public. We teach them on a public data, but also companies, they do have their own data. We get a consent from them to use by the student, so we can test their skills they learned on a virgin data. Nobody touched that before, we call it. So that is the challenge. Now it's a 7-month. We just started this month, and the students, seems they are going to start with their first project now. And they are enjoying the course, but that is the challenge we have now. how did we handle that? It's to work together with the industry side by side. Even during the delivery, we have an academic from Cambridge and we have a experts from the industry to support the learners to learn and they get the best of the both worlds.
And I can imagine there's a need for some sort of dynamic approach to that as well, because the industry's so much changed in the last couple of years. Does that mean that the expertise demands are also changing very quickly, or is there a common thread that you can work with?
Well, there is a common thread, but having new tools and new tools. I mean, just Google released Gemini, and that's a new skills they have to learn and tested, and see how others feel about it, and comparing to ChatGPT or Claude 3 or Copilot. I mean, that's all happened in the last 12 months, and then of course reacting on that, reflecting on the material. Teaching material, it's a challenge. It's not an easy, and find the right person. Of course, people who had this experience, they are on demand, and it's hard to secure these kind of human resources as well to deliver the course. So yeah, there are challenges, and we have to act dynamically and be adaptive quickly for changing the material, bringing the right partners, the right data, the right skills. Yeah.
Thank you very much. And John, did you have anything to add on where what you know to be best practice is difficult to implement? And
Yeah. I was going to talk about maybe the flip side of the coin, because I think a lot of our discussions at the moment, assuming that we've got well-meaning, well-intentioned people, well-intentioned companies, industries who are trying to seek to do their best ethically and regulatory and with appropriate data and so on. But you know, there is a space here for bad actors in the system, unfortunately. Digital transformation of human life will happen in a good and bad way. Unfortunately, I think there are going to be two streams to this. Individuals are very capable now of making their own large language models by following a video guide if they wanted to. And having that data then is, of course, going to enable them maybe to do bad things with it. Data is already a commodity in quite a strong way, but I do think we have to visit data security and even the risks of open data as well. We live in a country which I think does very well in producing lots of publicly available data, but that could be twisted in a way that we might not expect. And when I speak of those things, we're thinking of grand work, you know, writing and implementing your own large language models, but there was recent examples of where just by using very clever prompting of existing large language models, you could get quite dangerous material, shall we say, which circumnavigated inbuilt and existing safeguards. And again, that's an emerging thing that we have to try and address as it comes on. I think my final point with ethics and regulation is yeah, it will rapidly evolve and it will rapidly change. And a story which I think can illustrate that is when the first motor car was introduced into the UK, it was law for a human to walk in front of the motor car with a large red flag to warn passers-by of the incoming car, because people weren't familiar with it. Now, of course, that's in distant memory, right? We don't now have people with red flags walking in front of cars. And I do wonder, in 20 years or 50 years, what will the ethical norms regarding AI and its use be? Likewise, will we have deregulation? That seems to be the common theme in history, that when we get more familiar with things, we deregulate because we're more comfortable with their existence. So, yeah, doing even a bit more future horizon, that one makes me quite curious about what the future holds.
Yes, and it's an interesting one, what the role of regulation is in all of this, and the role of bad actors, and how you go about evaluating something before you put it out to market. not knowing what the people out there are doing. I don't know if anybody's got any thoughts on perhaps some of the evaluation of these things, or how to manage the risk of something that you haven't thought of before, and how that can turn things, and the role of regulation. Fatima, did you?
Yeah, so carrying on from the discussion, it's very, very interesting point that John brought up, and Janet touched upon keeping financial data in silos. We are facing this in healthcare as well. So data has to be kept within the trusted research environment or secure data environment. That's making the data silos. However, like efforts at this point in time is on enhancing these digital platforms to bring data and federate together. Alongside that, what is happening in terms of our progression towards development of these new ethical or legal requirement is documenting what is at the moment being practiced, because at the moment there are quite a lot of bubbles. So each institution holds their own data, applies their own rules into it. So understanding what is it that we currently are working on, the data flows that is flowing into these secure environments, is building the basis of developments that are going on in terms of developing the standardization and common frameworks. So a lot of projects have been focused on understanding the current to develop on it for the future. So we know, for example, Data Protection Act puts some specific requirements, but that was developed in 2018 before we had these massive AI consideration. And in my academic capacity as well, we are facing what John mentioned in terms of the diversity of assessments for students. For example, when we ask these questions, even if the data is provided within the course, within this, the defined governance, we know that the answers can possibly be aided by AI models. So we kind of going on defining more diverse assessment methods in academic practice to ensure that we have a way to evaluate the outcome that we are receiving by the human eye, rather than being blinded by what we receive from AI and then call it a high quality output, whether in research practice or in academic practice. So it's quite a lot of considerations, I think, that is bringing our past knowledge to the current point, where we now have to balance between human and machine interactions into every single process that we are facing.
That does also bring us nicely onto how this is possibly changing the skill set required of data scientists as the AI is getting more and more developed. And you touched on this yourself when you talked about the course that you've developed for this demands and the changing demands and skill sets. But can anybody comment on how they have felt their own approach to work changing, or whether there's a narrowing gap in between the people finessing really deep code and the people just buying off the shelf and little in between, or how is it changing things for data scientists?
Well, let me just comment on that. And regarding the what does it, the terminology of data scientist, or when we talk about data, we immediately link that with the statistics. And statistics it's an old topic, and there is an accumulation for 100 years, to the best of my knowledge, or more, in statistics. And people who are new to the data analysis or data, they have to have some learn about this legacy, and we face that when we develop the course. We should mention these skills and the statistics to build this knowledge on the top. And then when we reach to the right point in terms in talk about learning or machine learning, supervised and unsupervised, and then we talk about LLM. These are the new skills they have to learn. And as I mentioned, it's a tricky when we teach the learners about, we have to provide with a simple data set to teach them something complex in the statistics. And then, because it's a danger to teach them both of them, they will lose their, we will lose them. They will the concentration, and it's hard to follow up. So little bit of statistics they have to learn, the basics, the normal distribution, the type, and that what does that mean when we have these distribution, the meaning for the data. And that is the point which I made earlier about people should understand, make sense of numbers. What does it mean when I say 0.56 in a health care, or is that danger? 60%, is that okay? Is it 60% in cybersecurity probability of attack today? Is that should I inform the police? Should I inform someone? Or that is important. Or for example, for the stock market, we have drop of 10%. Is that something we have to scare? So making sense of numbers is part of it. And that is the part of the personalized learning, because depending on the background on what they have learned. So while the challenge we have, it's not straightforward, and it has to be personalized for people, because we are not taking people now, an 18 years old coming from all A-level. No, it's a wide range, diverse courses. People would like to approach this data science course. And we are in the era of people who are in social science and engineering, doctors, journalism, arts. They are all in charge to do about learning a little bit of data science and utilizing the AI for their benefit. So there's no one answer, sorry, and I can't say that, but it's I make it more complicated probably, but this is...
There's no silver bullet then. Interesting what you say, though, that people need to still be able to make sense of numbers. It sounds, there's often talk that AI will devalue knowledge and devalue experience. It sounds like perhaps you don't feel that's the case.
I'm still, I have to stick with the following. Please, whoever listen to me, please, human value, it is the value, and AI without human, it was nothing. And I have one example. In 1997, there's a software developed for chess playing against a human. And for the first time, the computer program, call it AI now, beaten Kasparov in 1997. Guess what happened? Did the chess disappear? No. Still, we are valuing human-to-human competition. If you beat an AI or AI beating you, it's fine. But if you were playing with the human, so the value in the human, same for the art and same for the musics. So the human value still we have, and we have to maintain that for the next generation. They shouldn't lose this human value and hand it to the AI value, which I feel it's a zero without the human.
Thank you. Does anybody else have anything they'd like to add? Yes, Janet?
I just to backtrack on what I was talking about previously about the teams and the talents. I think one of the things we are seeing is that diversity in people's backgrounds coming into data science, which is fantastic, because I think that really helps with the understanding of when things can go wrong and how things can be misused. if you have this cookie cutter set of people that have all got a degree from the same place and all had the same experience, which is very specific, this happens a lot in the financial industries. There's like 5 universities that all feed into the banks, and then they all think and solve problems in the same way because that's how they've been trained. But as soon as you start bringing in people with different backgrounds who think they're the ones that say, hang on, this is a problem. So I think having those different backgrounds is really useful. But then that training that Ali said, there's so many people who call themselves a data scientist that don't understand data or science. And I think really understanding that, because he was absolutely right. If you've got a probability of 60% or, you've got a sort of a small standard deviation, when is that an issue? What do you really understand about that based on your industry and based on your statistical knowledge? And that's so, so key. And it's something that a lot of people who self-trained and call themselves data scientists have missed out on. And when we look at what's being asked, so I think back to your very original question about, is it harder or is it easier? In some respects, it's a lot harder because someone who calls himself a data scientist now needs to do everything from basically fundamental research of trying to make models better. You've got to understand statistics, you've got to understand machine learning engineering, productionization, efficiencies, effectiveness, ethics. It's this huge, huge sphere. And it's too much for one person. So you've really got to have good balanced teams and support, because you can't keep on top of your game across all of those spaces. It's just not possible. So I think that becomes really difficult. But when I look at how things have changed, there's so many basic principles from, the 80s, 90s into standard good quality computer programming and testing. And I think the one thing that we're really missing as an industry is a specialist AI testing role, someone who understands enough about how models work and how they can go wrong, who can do the same thing for AI solutions as a good QA analyst can do for standard software engineering models, and really test them to extremes with, what happens when I put the wrong data in. I mean, we saw this, and there was a couple of days under COVID where all the numbers went wrong because the data hadn't been delivered correctly, or not enough of it had been delivered. And there were no checks in place to say, actually, we've only got 10% of what we were expecting, so don't automatically publish these results. And it's things like that that we really need to make sure are built into the systems, because those are the things that, again, could cause problems. Because as soon as you get a model that's not doing the right thing, going back to our original, when do they go wrong? You can then have a company then pulls that model that could be easily fixed, and then they're disillusioned with AI, and then they won't use it, and then that's that whole project and all of the expense and investment on that just thrown away, when a bit more testing and understanding could have saved that whole project.
Right. So it sounds like there's a lot of learning still going on. There's a lot of new expertise still being worked out, and a lot to do, and a lot of challenges to keep everybody on their toes and keep it exciting. and it does sound like there's a lot of positive input on the horizon from AI as well, and really seems convinced of that. I'm afraid that's all we've got time for, but thank you very much for all your thoughts. They've been really interesting and really valuable, and I'm sure people will enjoy hearing them. We do have a set of articles on the Real World Data Science website where you can find the full series on AI, and we'd love to hear what you think of it on all the usual social media channels. But for now, thank you very much for watching.